All right. Let's try to do some applications. You see, matrices can also be used to solve simultaneous equations. Those of you who have covered simultaneous equations, I'm sure this method was given to you. For those ones who missed maybe the lessons, here is an easy way. So we are handling matrices, using matrices to solve simultaneous equations. Now, some of you are who are wondering, what are simultaneous equations? Simultaneous equations are equations which work hand in hand. Yes, if you have two unknowns, you have two equations. If you have three unknowns, you have three equations. If you have four unknowns, you have four equations. It always works like that, and it always brings square matrices. Square matrices are the ones which have equal number of rows and columns. For example, a 2 by 2 is a square matrix, a 4 by 4 is a square matrix, like that. Now, when they give you a question like this, remember the method is row by column. So we come here and we write it in matrix form. Now this is how we write it in matrix form. We pull out everything. Remember, it was this times this plus this times this. So we come and we say where x is, we put 1, because the coefficient of x is 1. Where y is, we put 2. The coefficient of y, basically here it will be 3 and here negative 5. Then we say x and y is equal to 4 and 1. Here you realize that if I multiply 1 times x plus 2 times y, I go back here, is equal to 4, which is this. If I multiply 3 times x times plus negative 5 by y, I go back here. So here I haven't changed anything. I have just represented the simultaneous equations in matrix form. This is very important when you're answering this question. If you miss a step here, you will get wrong answers. Always find a way of representing this. Now let's continue. We know from our earlier work, we understood that a matrix times its inverse will give us an identity. So given this, let us call it matrix A. Let, it is okay to always let, so that you know the person, so that you let the person who is going to mark you or check your work know what you're doing. So you let matrix A be equal to this very matrix 1, 2, 3, negative 5. I hope you are together. So you say let A be equal to this. So you find A inverse. A inverse will be equal to 1 out of the determinant times A transpose, or the adjoint. So you say we find the determinant of matrix A will be equal to the leading diagonal minus the product of the leading diagonal minus the product of the others, which will be 1 times negative 5, the leading diagonal 1 and 5, then minus 3 times 2, 3 times 2. If you feel you are lost, or if you have any questions, or you feel you can't solve any problems in mathematics, feel free to comment in the comment section below. I will answer you as soon as I can. So shall have negative 5 minus 6. This will give us negative 11. This is our determinant. Then we find our adjoint or our transpose. So A transpose, like we said earlier, is we change the members of the leading diagonal and then the signs of the other diagonals, change the signs. Here shall have negative 5 and 1. Then our 2 will become a negative and our 3 will become a negative. This is our adjoint. So our inverse is equal to 1 over negative 11 into negative 5, negative 2, negative 3, and 1. This will be equal to, when you simplify, the negative here, it enters with everything, and I'll be having a negative cancel. Remember, a scalar multiplying a matrix. When you're multiplying a matrix by a scalar, this scalar enters everywhere. So I'll be having negative 5 over negative 11. We have negative 2 over negative 11. Then we have negative 3 over negative 11 and 1 over negative 11. So the negatives go on cancelling and shall have our A inverse to be equal to 5 over 11, 2 over 11, 3 over 11, and negative 1 over 11. Here the negative remains there because we didn't have the other negative for it to cross with. So we get our A, we put it in our formula here. So we have our matrix here, we multiply, so we have our, we come back to our equation here, which is 1, 2, negative 5 and 3 into x and y will be equal to 4 by 1. Now when we are multiplying, we introduce forgive me here, I need to wrap this. I don't know where the duster was put, but this would be equal to 4, 1. So I will multiply here with the inverse, which is 5 out of 11, 2 out of 11, 3 out of 11, negative 1 out of 11. Then we also multiply. The reason why I rubbed area is because I wanted to create space. In matrices, order matters. Once you change the order, you will get wrong results. So here I've multiplied here, also here I multiply. I will have 5 out of 11, 2 out of 11, 3 out of 11, negative 1 out of 11. If I had put this one here, checking compatibility, this would be, this is now a 2 by 2 crossing it with a 2 by 1, meaning our, this one, since they are compatible, our answer would be a 2 by 1. If we had done it the way around, it would have been a 1 by 2 multiplying a 2 by 2, which would be undefined. Now that is the importance of order. But from our formula, this is A and this is A inverse. So from our formula, where we are right now, from our formula, this multiplication should be giving us an identity matrix. Now the identity matrix, we talked about it in the earlier. The identity matrix here would be 1, 0, 0, 1. This is automatic. An inverse times it's not a matrix times its inverse, you always get the identity matrix, which is x and y would be equal to, we now work out this one. So I have 5, this times this plus this times this. 5 over 11 times 4 plus 2 over 11 times 1. We are expecting to get a 2 by 1. This would be 3 over 11 times 4 plus negative 1 over 11 times 1. If you feel you are lost, please in the comment section put your issue. In the next video I'll answer you. Next we'll continue. This 1 times x is x plus 0 times y is 0. Then 0 times x is 0 plus 1 times y is y. Whenever you're multiplying an identity by a number and they are compatible, you always get this one. This one will be equal to, we simplify this one. So we have 5 times 4 fractions. I told you check in the earlier ones. This one would be the same as, this is 5 times 4, which is 20 out of 11. 20 out of 11 plus 2 out of 11, and this is 12 out of 11. 12 out of 11 minus 1 out of 10. So x and y will be equal to, this is they have the same denominator as you add the numerators, 22 over 11 and then 11 over 11. When you simplify this one, 22 divided by 11, you remain with 2, and 11 over 11 remain with 1. Now here, most of the people think that once you reach here, you've solved the equation, but no, you're missing a step. The equation that was given to us earlier was in this form. So it is important to say, therefore, x will be equal to 2 and y will be equal to 1. If you leave it at this step, you're basically leaving it in matrix form. This is how you can use matrices to solve simultaneous equations. If you have a comment, Don't forget to subscribe, follow, like. Thank you.